Scientists may have just uncovered what may be the biggest change in physics thinking since Einstein's theories of relativity. Thanks to the recent reignition of the Large Hadron Collider cosmic gun by physicists at the European Centre for Nuclear Research, CERN, a revolution is about to happen. And their discovery of new particles has set us off on the big game of understanding more about the nature of the cosmos. What may be the key to unlocking an entirely new perspective on the universe lies in these unidentified particles. So, join us as we explore this startling discovery that fundamentally changes everything. The Higgs Boson, a subatomic particle without which many of the other particles we're aware of would lack mass, was one of the greatest discoveries of our generation. The origin of the universe after the Big Bang 13.7 billion years ago, and the energy field it's connected to, are believed to have depended on this particle. Physicists at CERN created headlines all over the world in 2010 when they discovered the Higgs Boson. The discovery was made through the aid of what is commonly known as a cosmic gun, but more technically known as the Large Hadron Collider, LHC. Optimist physicists asserted that the universe was up for grabs and that the Higgs Boson was the collider's intended target when it was first turned on in 2010. The Standard Model, a system of equations that describes everything researchers have been able to measure about the subatomic world, was all built based on the discovery of the Higgs particle. But after a decade after the discovery of the particle, there were no more groundbreaking findings. This raised some concerns due to the fact that the LHC was publicly funded and cost £3.6 billion to build, with an annual expenditure of £1.1 billion. With that much money being spent, people's expectations and hopes were that a fifth force, dark energy, or some other paradigm-shifting particle should have been found. The science community had been hoping for proof of, at the very least, a fifth natural force in the universe. Because, although we know a lot, we're still missing nearly everything. The four forces that are currently known in physics are gravity, electromagnetic, two nuclear forces, and gravitation. The LHC was expected to make discoveries that may help to shed light on some of the mysteries surrounding dark matter and other topics. We know the majority of the cosmos is made up of dark matter because we can find its gravitational signals. The cosmos is filled tightly with dark matter, and its strong gravitational pull prevents galaxies from colliding, and it's in charge of the universe's expansion. However, the rest of the composition of dark matter is yet unknown. It has been difficult, if not impossible, to measure since it's so mysterious. The most current studies show that it's 5 times heavier than visible stuff. And since less than 5% of measured matter, including human tissue, is known matter, the pressure is on for scientists to uncover more of the unknown. CERN researchers have been metaphorically under the cosmic gun to deliver. However, CERN's top scientists have made their case for the investigation's upcoming phase. They were motivated to make upgrades to convince the governments of member nations to commit to a significant increase in spending. Thus, after a 3-year hiatus for improvements, the biggest and most potent particle collider in the world was started up again. The enormous collider had to undergo some repair, but even before then, the collider has been producing evidence that the universe might be hiding something remarkable. Simply speaking, it worked by smashing atoms together to disassemble them and reveal their internal structure. Its software was improved to allow it to take data at a rate of 30 million times per second. Its instruments were also made more sensitive, allowing researchers to study the collision of particles from inside atoms in greater detail. And its beams were made narrower, which significantly increased the number of collisions. All of this improved the LHC's chances of discovering subatomic particles that are wholly novel to science. For the first time, according to researchers, 3 previously unseen particles have now been found. According to CERN, their latest finding represents a tremendous step forward in our knowledge of the cosmos. Because of the updates, researchers can now analyze 20 times more collisions. Every 20 meters, a new subdetector was added, with the first one being near the collision location. According to CERN, the LHC operates by colliding 2 beams and then recording the results using specialized equipment. At 4 locations around a ring, the 2 beams inside the LHC are designed to collide or strike one another. These collision locations house 4 particle detectors. They're known as the ATLAS, CMS, ALICE, and LHCb, and each one conducts a distinct experiment. From what we were able to find out, the ATLAS and CMS covered the entire collision spot with an enclosed detector, and while the LHCb uses some detectors to study forward particles. These are the particles that the collision in one direction has propelled ahead. The ATLAS device is a 46-meter long and 25-meter high detector, and it examines the particles the LHC produces. During operations, protons, which make up the atom's core and are driven to speeds close to the speed of light around a ring with a radius of 17 miles, collide exactly in the middle of these enormous detectors. Smaller particles are also produced by collisions, and these scatter in various directions. Like identifying the species and features of an animal from its tracks, the detection system follows their course and energy, and it's this trail that reveals to the scientists what kind of particle it is. Most of these smaller particles produced by collisions are already well known to science. Shockingly, during a test run of the upgraded detector and the LHC, the neutrinos, which are extremely small particles, were discovered. The groundbreaking discovery achieved by CERN's forward search experiment Phaser Group marked the first time neutrinos have been spotted inside any particle accelerator, not just the Large Hadron Collider. The discovery provides researchers with a brand new lens through which to study the subatomic universe. The physicists discovered that some of the marks were caused by neutrinos by developing the emulsion and by examining the particle trails left behind. They were even able to identify which of the 3 neutrinos types they had identified. This demonstrated that scientists had not only chosen the best location within the enormous 27-kilometer ring to look for neutrinos, but that their new detector was capable of doing so. According to physicists, the precise nature of these unusual particles is unknown, but they're confident that existing hadrons will be better understood as a result of the recent discovery. It's interesting to try to comprehend why a 27-kilometer-long instrument is required to detect particles that are many times smaller than an atom. But physicists are already searching for signs of new particles, which could result from more collisions. In fact, CERN will shortly present plans for an even larger Hadron Collider, but so much depends on further findings the researchers produce over the next few years. The Future Circular Collider, FCC, the most ambitious proposal, is for building a ring 60 miles in diameter beneath Lake Geneva. The anticipated cost of the FCC is an astonishing £20 billion. However, the current LHC still has some more years to go, and with several improvements, it can have even more power to try to find the particles that will fundamentally alter physics. According to physicist Niels Tuning, the more thorough studies we undertake, the more kinds of unusual hadrons we find. Adding that we're living through an era of discovery akin to the 1950s right now. At that time, fresh insights into subatomic physics emerged when new subatomic particles were identified. For around 4 years, the upgraded Large Hadron Collider will continue to operate at 13.6 trillion electron volts. And certainly, when more analyses are conducted, more diverse, unusual particles will be discovered. Already, researchers at Fermilab, the US equivalent of the LHC, have even found what may be the first fracture in the standard model. Members of the LHC will be aiming to validate their findings over the following months and years, and discover several further cracks in the existing theory, until it disintegrates to make room for a new, unified, and more thorough view of how the universe functions. So, do you think this discovery will really alter our understanding of the cosmos as scientists tell us it will? Let us know in the comments. If you enjoyed this video, don't forget to like and share it, and also subscribe to the channel for more. See ya on the next one.